Okay, so I am now assuming you've made it through the background material here. So you've gone through the overview, you've gotten some exposure to LaTeX, you've gotten some exposure to Python, in particular, doing elementary row operations and putting it into reduced row echelon form. So we're working on questions 1, 2, 3, 4, and 5. And as you're working on these questions, if you forget how to do something, you can just go back up through the table of contents to go over and read again how that the instructions about how to perform those operations in Python. But I am not going to read anything that you enter. The first thing I'm going to look at in your document is what did you enter in question 1. So question 1 over here is saying, okay, let's enter your birthday month and your birthday date. This is a question, so hopefully you think long and hard about this. So my birthday is June 12th, so my birth month is 6. And just recall, well, how can I edit this text cell? I can click on it and click the pencil over here, or I can just double click. And over here is kind of the unformatted text. And on the right is what that text looks like when it's going to be formatted. So my birthday month, rather than type June, I type 6, and you can see that it appears over here. And my birth date is the 12th. So I'm going to type a 12 over here. No need to send birthday presents to me, but keep that in mind, June 12th. Great. I just got credit for question 1. So that's all you need to do in question 1 is type in your information here. Question 2 is not asking me to enter text. So this text cell has the instructions for the question, but rather it's asking me to fill stuff in the code blocks below. So this first code block, this is entering the matrix that you see up here in Python. So it has assigned this matrix A. So the first part of this question is asking you, how could you pull off the entry in this matrix for your birth month? Okay, my birth month was 6. So how can I get this entry in this matrix? And if you don't recall how to do this, go back and check out indexing arrays, Python indexes at 0. So let's say I'm not thinking too clearly about this, and I think that my birth month is located in array A, row index 1, column index 4. Okay, notice I don't see any output over here. So if you want to check your output, why don't I go ahead and type month over here? Now I can see that gave me a month of -5. Why do I have a month of -5? I don't have a -5 anywhere in this matrix. Hopefully you caught my mistake, right? I forgot to first load matrix A. So I had matrix A that I was working with earlier in this document. And this is where it sometimes can be problematic that things are by default objects that you've previously defined are read into later blocks, they're saved. So I want to not use matrix A, which I was working with earlier, but I want to define a new matrix A. So running this block of code is going to redefine A and what's stored in A. And now running this block over here, I can see that this is telling me the month is 13. My month was 6, so my answer is not correct here. I need to think about what are the indices that I'm going to enter in so that I get this entry over here. So hopefully you recall that this is located in the first row of this matrix, and this first row we begin counting at 0. So this would have row index 0, and then we similarly need to count out the right column. So that's for you to figure out, which is what would be the right way to index it. Over here, I'm trying to do the same thing, which is how can I figure out how to pull off my birth date. So in other words, my birth date is 12. So I'd want to figure out how would I index this entry, where this entry 12 lives in this matrix. So I could try entering something over here, and keep in mind that you won't see the output. So you won't be able to check your work. If you want to check your work, then you actually need to either type the variable date, or you can use a print command. And now you can check your work, and I can see that I made a mistake. So I want to figure out what are the indices that I would use so that this date has the value 12 saved to it. So you want to play around with these indexes and make sure that you're clear about how things are properly indexed in Python. Check out this index array section over here. Okay, question 3 on the assignment is going to ask us to do some work with elementary row operations. So if you haven't read the overview section on elementary row operations, I would direct you back over to this section of the document before trying to answer question 3. So question 3, the first thing you'd want to do is be sure that you reload matrix A. So we were working with something called matrix A in the previous problem. We now are defining a new matrix A. So before I run any of these other blocks of code, let me first load matrix A over here. And what I could do lots of different operations. So some operations I've done, and I'm going to want you to come up with your own other elementary row operations. So let's say the first thing I want to do is a scaling operation on row 2 of this matrix that we just defined. So if I'm scaling row 2 of matrix A, that means I'm doing something to the row that has index 2 minus 1, right? Because indexing starts at 0 in Python. So I want to take the row that has row index 1 and multiply all of those elements by 6, and then show the output to the screen. So now I can see that this second row, everything in here was multiplied by 6. So now what I'd like you to do is come up with your own operation down here. So you can scale any of the rows, 1, 2, or 3 of this matrix by any factor that you want. But I want you to come up with your own row operation over here, own scaling row operation. Okay, then I defined a replacement operation. So I want you to run this replacement operation. Then I want you to come up with your own replacement operation. So answers are not going to be unique. You're welcome to come up with your own result here. I do an interchange of rows, and then I want you to do an interchange of rows. So in this question, some of the operations I've defined, I want you to run those, and then I want you to write in code that's going to run some of your own operations. And at the end of this question, you're going to have performed 2 scaling operations, 2 replacement operations, and 2 interchanging operations. And then you're going to run this last line of code, which is going to print to the screen what your new matrix A is. So now you're going to have some matrix that is not in reduced row echelon form. Notice, this matrix that we started with over here was in reduced row echelon form. We've done some operations to it. Right now, it's no longer in reduced row echelon form. So the end result over here, you're going to get some matrix which is not in reduced row echelon form, but is row equivalent to the matrix that you started with. So depending on your row operations, you're going to get different outputs in question 3. Then in question 4, what I want you to do is type in LaTeX code that's going to typeset the resulting matrix that you get out of this last step over here. And then in part B, take that matrix, and if it were an augmented matrix, what would the corresponding system of equations be? So if you get stuck on this, certainly recall that way back at the start of this document, there was a bunch of stuff about LaTeX, but down below you can see, like, if this were the output that I got out of this last line of code over here, then the first thing that I would want to enter would be enter this matrix in the B-matrix environment. So you can see I took this output, hypothetical output from Python, and I typeset it using the B-matrix environment, which gave me this nice matrix. So in your answer in question 4, you're going to want to replace this thing here with some piece of LaTeX code that looks like this. So it's very handy. You might just want to copy and paste this over here and then tweak that code. You're going to have a 3x5 matrix. So you're going to have a very different looking matrix, but at least you've got the kind of template for how you can enter a matrix, a bracketed matrix in LaTeX. And the second part of this question, part B, is then saying, take this matrix that you just entered in the B matrix environment and typeset this as its corresponding system of linear equations using this array environment that I talked about earlier in this document. So question 4 is not asking you to enter or tweak any sort of LaTeX code, but rather fill in a B matrix environment corresponding to the output that you get right here, and then corresponding to this matrix that you have typeset in the array environment, what the system of equations would look like. Whew. Okay, and then question 5, very last question. It's nice when question 5 is the simplest question on the assignment, the very last one, is let's check to make sure that the matrix you got in question 3, after doing all of these operations, is actually row equivalent to this matrix that we started with over here. So at this point, I'm assuming you've gone through and you've run all of these codes, blocks of code, and you haven't executed anything. The last thing you've run is this thing right before question 4. So what's important is you want matrix A now to be defined as the result after doing all of these 6 elementary row operations. So when you come to this last block of code in question 5, matrix A is now what's being read in is the last matrix that you had in your previous block of code. So after you run this line of code, you hopefully should see that the output is exactly equal to this matrix. It equals the matrix that we started with. So this last line of code is going to undo the previous 6 elementary row operations that we did in question 3. So you can check your work. After you enter this, you should get this matrix back. And if you don't, that means you did something wrong in question 3, and you can go back and try and figure out what might have happened. And if you're unable to figure out what might have happened, then just shoot me an email. And if anybody is having trouble with Google Colab and getting frustrated with it after, trying to spend a little bit of time practicing it, if you're having some trouble, that's totally understandable. I would definitely encourage you to reach out to me to find a time where we can get on Zoom together and have a discussion back and forth about it to try and help clear up any confusion you might have with working in Google Colab. So once you're done with your assignment, then what I want you to upload is your work from questions 1, 2, 3, 4, and 5. You can either decide to delete elements of this. I don't think you really need to. After you've entered all of your answers for questions 1, 2, 3, 4, and 5, just make sure that you save your document. It should be saving things automatically, but you want to make sure you save your document. Note the location where it's saved on your computer. And then when you want to upload this, you would just come into our Canvas site, go over to Python Lab 1, And again, click Start Assignment, choose the file, and then just find the file, the folder where you just saved your previous thing, and upload this file and click Submit. And the only file type that this is going to be allowed to submit is going to be a .ipynb file. Okay, so good luck on the assignment, and if you have any trouble, just let me know.